We are on block 4 from topic 4, and this is page 113 out of your book. So you need to make sure you are on 113 in your book. First thing we're going to talk about look at is I looked up the hummingbird feed recipe, and it said that there is 1 cup sugar and 4 cups water for the hummingbird feed recipe. How would I make this feed sweeter? Adding more sugar. Is it going to be the same recipe?
No.
No. Am I exactly doubling the recipe?
No.
No, if I want it sweeter, I'm just editing the recipe and adding more sugar. What would happen if we added more water?
It would become less sweeter.
It would become less sweeter. So when they came up with this hummingbird feed, the old hummingbird experts, they studied and they found that this recipe is what they liked. If it had too much sugar, it was too sweet for them, and if it had too much water, it didn't have enough sugar for it. One of my fun facts I did a few years ago, it had I forget how many, but how many calories a hummingbird burns per second. Because their little wings are going so fast that if they're not constantly drinking some type of sugar water, which you get sugar water from flowers, so if they don't have feeders that they're feeding off of, they'll be on flowers. If they're not constantly getting that, they'll die because they're burning so many calories just flapping their wings, because they're little hyper little fellas. They're little cute guys though. Alright, so we're going to be talking about some mixtures today. And this is going with problem 1 in your textbook. So we're going to read, it says, Haley and her teammates are making lemonade. They make a sugar water solution by dissolving sugar into hot water. In another container, they squeeze lemons to form pure lemon juice. They mix the 2 liquids together according to the following recipe. So we have a recipe that's a mild, regular, and then super sour. And it looks like what's happening going from mild to super sour. There's more lemon juice and less sugar water, making it a little more sour. So number 1 says that if the team wants to make 10 quarts of each type of lemonade, how many quarts of lemon juice do you need for each recipe? Okay, well, let's look at mild first. So for mild, I'm looking at lemon juice or sugar water. What did it say? I'm looking at lemon juice. And what is the percent of mild for lemon juice? 10. Do you agree 10 over 100 means the same thing as 10%?
Yes.
Okay. We're just using our proportions that we are used to working. Okay, so I need to come up with another fraction of something that I know. And they told me something about 10 quarts. Is that going to be part or my total? Total, which I meant to say part or whole. It is my whole. So it would go on the bottom. And you know what I got to thinking today? I kind of had an aha moment. And I don't know, it was kind of a brain fart. But you know how it is part over whole is the way we write it? I was like, wait a second, that makes sense, because isn't a fraction the numerator part of whatever the bottom is? So fractions are parts out of whole, and it all made sense to me. I was like, okay. So you can still learn at 32 years old. I just thought people said, let's go part over whole, and then I was like, a fraction is part over whole. Okay, side note there. So, if I needed to find how much lemon juice was in this, what two numbers am I multiplying?
10 times 10.
10 times 10, then I divide by 100, and I am at 1. 1 what?
Quart.
I need 1 quart of, what were we looking at? Lemon juice. So 1 quart of lemon juice would be needed. Now I have to figure the regular. What percent of lemon juice is the regular?
15.
15 over 100. Again, we're making 10 quarts. Is that my part or my whole?
Whole.
My whole, so it goes on the bottom. This time I'm multiplying 10 times 15 divided by 100, and I get 1.5 what? Quarts. So that's how much it would call for lemon juice of the regular. Now the super sour. How much lemon juice is in the super sour?
20%.
20%, so 20 over 100. How much do I want to make?
10.
10, so that's going to be my whole. Again, multiply 10 times 20, divide by 100, and I am at
2 quarts of lemon juice.
2 quarts of lemon juice. Oh, not too bad. All right, let's take a look at problem 2. 2 says the team wants to make 20 cups of mild lemonade. How much of each ingredient should they put in? All right, well, I don't see the recipe here, so what is the mild recipe?
10% lemon juice and 90% sugar water.
10% lemon juice, 90% sugar water. Well, doesn't those make sense because it's adding up to the whole picture, which is how much percent?
100%.
So, did all the recipes make sense and add up to the whole picture?
Yes.
Yes. Question?
For the lemon juice, could all you have to do, because when we found 10 quarts, it was 1, so wouldn't you just double it to find the amount of lemon juice?
But, were we looking, oh, you looked at the mild?
That's cups, never mind.
Yeah, we're looking at cups this time. Good thinking, though. Alright, so we have to find how much of each ingredient we need. So we need to look at each ingredient. Obviously, LJ is standing for lemon juice. And I need to find how much lemon juice I need. So I know lemon juice is 10% of the whole container. And they should have given me one other piece of information, either a part or a whole. I see 20 cups. Is that my part or whole?
Whole.
My whole. So 20 cups is on my denominator. Now I can find lemon juice. So 20 times 10 divided by 100. How much lemon juice?
2 cups.
2 cups lemon juice. Okay, now I need to figure sugar water. What percent is sugar water?
90%.
90%. How much are we making?
20 cups.
20 cups. That's the total amount, the whole. So I have 20 times 90 divided by 100. And how much sugar water do I need?
18 cups.
18 cups of sugar water. For a bonus point, raise your hand. What would have been a quicker way, instead of solving for sugar water, could I have done instead of doing all my proportional work? He had raised his hand first.
When you figure out the lemon juice, you could have just did 20 minus 2 for lemon juice, because you know there was already 20 cups.
Alright, I'm going to repeat that for the video. He said we already knew there were 20 whole cups in my container. 2 of those cups were going to be lemon juice. So he knew 20 minus 2, there had to be how many cups of sugar water? 18 cups. So that's going to save us some time if we didn't want to sit here and calculate all this out. So bonus point card goes to you. All right. Let's take a look at problem 3. It says the team wants to make 15 cups of super sour lemonade. How much of each ingredient should they put in? All right, so again, I don't have the recipe in front of me. Could you tell me what the recipe for super sour is?
20% lemon juice, 80% sugar water.
Lemon juice, 80 sugar water. All right, what ingredient do you want to look for? Does it matter which one we look for first?
No.
All right, which one do you want to look for?
Lemon juice.
Okay, I heard lemon juice, so let's look for lemon juice. And what is the percent of lemon juice I need? 20. And I see 15 cups written in my problem. Is that how much total I need, or is that part of something?
Total.
That is total. So I have 15 times a 20 divided by 100. And I'm at how much lemon juice?
3 cups.
3 cups lemon juice. Okay. Do you want to do the proportion or do our little shortcut?
Proportion.
Alright, if you want to do proportion, go ahead. I'm going to do the shortcut. How many total cups do we know we have? 15 total. And we know 3 of those cups are lemon juice. We're taking off. So how many cups we have left? 12 cups would be, what are we looking at? Sugar water. 12 cups of sugar water. Does 12 plus 3 give me my 15?
Yes.
Yes, it does. Okay, one more relatively easy one, and then we're going to have a problem that kind of stretches our brain some. Not too bad. Problem 4 says the team wants to make 15 cups of regular lemonade. How much of each ingredient should they put in? Alright, so help me out one last time. What was regular lemonade?
15% lemon juice and 85% sugar water.
85 sugar water. Okay. What ingredient do you want to look for?
Lemon juice.
Okay. Let's change it up. I want to look for sugar water. I want to be different. 85% is sugar water. I need another amount. I see a 15 cups. Is that talking about a part or a whole? A whole. So it goes in the denominator. Multiply, divide. How much sugar water?
12.75
75 what?
cups.
Cups of sugar water. Shortcut or proportion?
Portion.
Some people just like the proportions, and that's dandy. I don't. Well, I mean, I do, but I like shortcuts too. So I need to subtract those 2, and how much is left for lemon juice?
2.25
2.25
cups.
cups of lemon juice. And those two should add up to 15. Now, number 5. The team has made 10 cups of super sour lemonade, but they really want 30 cups of mild lemonade. So did they even make the right lemonade?
No.
No. How many cups of lemon juice and or sugar water should they add to make 30 cups of mild lemonade? So let me kind of talk this out first. I have a small container and a large container. The small container has what in it?
10 cups of
10 cups of super sour lemonade. I want a big container, but what do I want in the big container?
Mild lemonade.
Mild lemonade. I don't want to throw the small cup away. I want to pour it in the big cup, and I want to see what else I need to put in the big cup that's going to make a mild recipe and not a super sour recipe. So I need to see how to edit that. Kind of makes sense. So to do that, I need to look at the small cup and the large cup and see what ingredients are actually in it first. So I'm going to look at my 10 first. My 10 cups of super sour. And super sour has 20% lemon juice. 20% lemon juice. And how much total was in the cup?
80. Oh, 100%.
How much total was in the cup?
Oh,
10 cups. So is that my part or my whole? My whole. So that's 10. Notice how I wrote my proportion kind of different. Is that okay?
Yes.
Because last time I checked, 2 equals 2 is the same thing as 2 equals 2, right? I can flop it around and it still equals each other, right? Okay. Some hard math we're learning here. So, I need to multiply 20 times 10, divide by 100, and how much lemon juice am I at?
2 cups.
2 cups. So, I could do my trick and know how much sugar water is in that 10 cups.
8.
How'd you get 8?
10 minus 2.
10 minus 2. So the lemon juice had 2 cups lemon juice, 8 cups sugar water. Now I need to look at what I need in the big pitcher. And this needs to be a mild recipe. So I need a mild percent. What do you want? Let's go lemon juice again. What percent is mild?
10%.
10% is mild lemon juice. What amount am I using? 30. Is it my part or whole? Whole. Multiply, divide, and for lemon juice I get 3 cups. So for sugar water, how many cups would be in the sugar water? 27 cups. So, I poured the small cup of super sour in my container. I need to see what else I need to pour in my container to make the mild mixture. Well, lemon juice, I need a total of 3 cups. How many cups of lemon juice did I really pour in?
3.
2. So I poured in 2. I need 3. So how much more do I need? I need 1 more cup of lemon juice. I poured in 8 cups of sugar water. How many more cups of sugar water do I need to pour in? 19 cups of sugar water. And when I pour those in, that will make the super sour mild for 30 cups. Okay, now we are at problem 6. It says for this mixture, so they're making a new recipe. 75% of the lemonade is sugar water, so that's why they already have 75% filled in on your chart. It wants you to complete the puzzle to determine the number of lemon juice, the percent of lemonade that is lemon juice, and the cups of sugar water. So what is my whole pitcher? What is the total amount there?
25.
25 cups. Okay, so I'm going to give you a little bit of time. I want the rest of these filled in using what we just learned. I have some numbers on the board you can choose from. You need to see a percent of lemon juice, the cups of lemon juice, and then the cups of sugar water. Alright, so if my container has 25 cups, it has 100% of it is in the pitcher. 75% of it is sugar water. So what is the rest percent of my whole pitcher?
25%.
25%. Okay, then we had to do our proportions to figure out either lemon juice or sugar water. And how much lemon juice do you think would be in this recipe?
6.25.
6.25. And then sugar water would be what?
18.75.
1875. And when we submit our answer, we were great. Wonderfully done. I want to look at one thing that is not in your book. It says for their science experiment, Sheila and Martha tried different brands of popcorn to see which one popped the best. Their favorite brand, Pop Delight, had only about 30% of the kernels popped. So you know when you pop popcorn and you have all the kernels left that didn't pop? So they said 30% were left unpopped in that brand of popcorn. Another brand, Pop King, had about 60% of the kernels popped. Oh, I said that backwards. So Pop Delight only popped 30% of its kernels. So it had a lot of kernels left at the bottom. Pop King had 60% of the kernels were popped. So what percent were unpopped? 40% were unpopped. They decided that if they combined the equal amounts of the two brands, they should be able to have 90% of the kernels popped. Is their thinking correct? Can you just combine the percents and they would be correct? No? Could you explain why not?
Because it's chance.
It's chance? It's up to chance? Not really. What you got?
Because every time it's only 60% of the kernels pop from that, which means if you combine them, so a lot of them are still not going to be popped. It's going to be the same percent, except it's going to be a different percent because there are two different types.
Right. Okay, so what you got?
I just thought because if you add the percent of the kernels not popped or popped, then you have to add the percent of the kernels unpopped. So then it'd be 40 plus 7, maybe 110 kernels unpopped.
What you got?
So if you combine the percents of the kernels popped, you also would have to combine the percent or the number of the kernels that are unpopped, which would be a larger amount.
Yeah. What you got?
I was just saying the microphone is not working. It's not doing its normal thing.
Okay. What?
Couldn't you just take the kernels that didn't pop and put them back in?
You could eventually. What if they're like dead? What if they're like dead kernels and will never pop?
Like
Gotta have something to it. I cannot just add percents, and this is a good model to show that. 30% really means 30 out of 100, right? And then 60 really means 60 out of 100. If I was to combine those and say it would be 90% out of 100, I'm not really saying the same thing because it would be 90% out of 200. So this is, if I combine 30% and 60%, that would produce that green section, but out of 200, which gives me 45% popped. So I can't just add percents and say that it's going to work out. You have, when you're adding percents, you're taking two whole groups and putting them together to get a different amounted whole group. Okay? So the rest of the class time, you have to work on your homework problems, problems 7 through 11. Pay attention though, because we are dealing with proportions, right? And we've been looking at part over whole, percent over 100, basically. Well, all the problems we did today was missing what part? What section? The part. It was missing the part. That doesn't always happen. Like some of your homework problems might be missing the percent and they give you the part, whole, and 100. So you have to find the percent. Or they might give you the whole and you have to find the part. So they don't always give you the same thing. You have to see what section is missing to find that. Alright, that concludes today's lesson. So, like, subscribe, hit the notification bell, and peace out, home dogs.